Welcome to T1 Academy. In our last session, we started discussing about the number systems and we solved we learned different concepts of this number system like our units, digit, remainders theorem, finding the number of zeros, factors and all those things. So today in this session, we are going to see some practice questions from all the areas. See here students, when it comes to these number systems, there is no particular strategy or we cannot expect that they will ask questions from this area, that area like that. Okay, usually the questions will be in a generalized manner. If you observe carefully, for each and every question, every point will be, or else every solution will be a new solution. Why? Because for each and every question, we need to go through concept. We should know the concept, then only we can solve the problem. So every question will be different from the other question. So we can frame number of questions from these number systems. So keeping that thing in our mind, we will try to practice some questions which are most frequently asked. That means similar questions. Not the same, later we will see the same questions also, but for time being we will see some of the practice questions from this number system concept. Okay, right. Now if you observe carefully, number 136 is added to 5b7. Okay, what they are telling us here is number 136 is added to 5b7. Okay, and the sum obtained is 7a3 and the sum obtained is 7a3. Where a and b are the integers. Okay, what they are doing is they are adding 136 with 5b7. Okay, and the sum obtained for that is 7a3. Okay, good, superb. Now, where a and b are integers, they are telling that a and b are two integers. It is given that 7a3 is exactly divisible by 3. 7a3 is exactly divisible by 3. What is the divisibility rule of 3? Sum of the digits should be divisible by 3. That means 7 plus a plus 3 should be divisible by what? 3. 7 plus a plus 3 should be divisible by what? 3. So what it becomes? 10 plus a should be divisible by 3. 10 plus a should be divisible by 3. Now 10 plus a, in place of a, what are the values I can take here students? Actually, in place of a, I can take 2. So that 10 plus 2 is 12, 12 is divisible by 3. And similarly, in place of a, I can take 5. 10 plus 5, it is 15. 15 is divisible by 3. Next, in place of a, I can take 8. 10 plus a, that will become 18 is divisible by 3. I cannot take 11. Okay, the next multiple. The reason behind that is very simple. What is the reason? It will become a 2-digit number. But actually, a should be a single digit. A should be a single digit. So, what are the chances of a I can take here is actually 2, 5 and 8. I can take 2, 5 and 8. Okay, now please see here what I can take. First I will take in place of a as 2. For time being I will take a as 2. If I take a value as 2, now what happens to my 6 plus 7? It becomes 13. Okay, 1 will go as carry and I will be left with 3. Now 1, 3, it will become 4. And if a value is 2, what is the sum I should get here students? If a value is 2 and definitely 1 should come as a carry. Then only 1 plus 5 is 6 plus 1 it becomes 7. So the total value of this value should become what? 12 for me. Total this value should become 12. That means 4 plus b should be equal to 12. Then b value will become what for me here? 8. B value becomes 8. Okay, there is chance for 8. And very clearly they are telling the only possible value for b is actually we have the answer 8. But for your understanding, we will check 5 and 8. If I take a value as 5 and 8, what will happen? We will look it for once. If I take a value as 5, obviously it should become what? 15. That is okay. 1 and 5. Now what happens to my b value? Please see here. 1 plus 3, it becomes a 4. 1 plus 3 is 4. That means what I should get here? 4 plus b should become what? 15. 4 plus b should become what? 15. Now what happens to my b value? It becomes 11. Which is not possible. What is the reason why b cannot be 11? Because it is becoming a 2-digit number. It is becoming a 2-digit number. That is not possible. Because of that reason, a as 5 is not possible. Now I will take a as 8. If I take a value as 8, what will happen here? Please see here, as usual, it should become 18. So 1 will go as a carry and I will have 8 here. That means 4 plus b value should become what? 18. The same problem with 8 also. See here, b value now becomes what? 14. Which is not practically possible for us. Because of that reason, the only value possible for b is what? 8. Or else the other way what you can do is by doing the value substitution. Okay, by taking the substitution, you need to substitute each and every value in place of a and try to verify it. But the thing is, once again you need to take the a value and you will get some other a values, you need to verify these, that and everything. Instead of that, if you go it for once, anyway, only one value will be suitable, you can directly get the answer. Okay, this is the process or method to solve this type of questions. Okay, next one. See here, the number of times the digit 5 will appear while writing the integers from 1 to 1000 is. See students, this is one of the most common questions. Counting of digits. How many times the digit? It can be 2, 5, 3, whatever it may be. Depending on his mood, they are asking different types of questions from this area. So counting of digits. How many times the digit 5 will be used here? Okay. So now what happens when here the question is 5, right? We should follow a particular strategy to solve this one. Why? Because to avoid repetition, where we will have repetition like 55, 155, 255, 355 and 555, there we will have multiple 5s, right? To avoid these conditions, what we will do is, how many times it will come at units place? How many times the digit 5 will come at units place, we will see. 0, 5, 15, 25, 35, 45, 55. In this case, I will count only the units place one. I will not count the tens place one. Okay, understand? Okay, 65, 75, 85, 95. So total, how many times the 5 was came for us in units place? It came for 10 times. Like this, the range is from what? The range is from 1 to 1000. But actually, the range which I have taken here is from 1 to 100. Like this, I will have how many pairs? Tell me, if 105 is one pair, 205, 305, 405, 505. Like this, how many pairs do I have here? I will have 10 pairs, right? So 10 into 10. That means in units place, it will come for how many times? 100 times. In units place, 5 will be repeated for, the digit 5 will come for 100 times. When it comes to tens place, usually from where we will get the first pair is 50, 51, 52, 53, 54, 55. Now see here, the tens one I will count at this place. Okay, 56, 57, 58, 59. How many I got actually? From 0 to 9, it is 10. But the same pair will be there for 150, 250, 350, 450, like this. How many pairs I will have? 10 pairs. Right? So 10 into 10. So in tens place, I will have 100 fives. Now when it comes to hundreds place, now see here students, when it comes to hundreds place, usually what we will have, from where it will start? From 500, 501, 502 and so on up to what? 599. Am I correct? So total how many times the 5 will be there at a hundreds place? The 5 will be there at hundreds place for 100 times. Is there chance of getting it at thousands place? No. Why? Because our maximum number is what? 1000. So that means the digit 5 will be used for how many times? 100 plus 100 plus 100. 300 times to write the numbers from 1 to 1000. Not only digit 5 students. If you check digit 2, digit 3, digit 4, all these digits will be used for 300 times to write the digits from 1 to 1000. Understood? So we should follow a particular strategy to count the digits. How many times the digit will be used in units place? How many times it will be used in tens place? How many times it will be used in hundreds place? If there is thousands place, you should count that thousands place also. Okay? Right. Next one. Consider the following statements. The sum of 5 consecutive integers can be 100. Now see here students, whenever you see these type of questions, what my suggestion here is, usually consecutive integers means side by side integers, right? Now most of the students, what they will take is first integer as a, next one as a plus 1, next one as a plus 2, next one as a plus 3 and the last one as a plus 4. Okay, this is correct, there is no wrong in taking like that, but this will take some more time in most of the cases. Instead of that, how you should take the consecutive integers means, okay, I will take one integer as a, next one a plus 1, next one a minus 1. I will take one forward and one backward. Now how many integers I came? Here I have 3 integers. Next I will take a plus 2, 4, next a minus 2, 5. Like this also I can say that these 5 are consecutive integers. Yes, I can say this also as consecutive integer. So, whenever you take consecutive integer, students, don't take in a continuous manner like this. Take 1 plus and 1 minus, so that it will be easy while calculating the things. Why? Because later while solving the problems, most of the things will get cancelled if we have plus and minus. Okay, so while taking the consecutive integers, please try to take them in this manner, so that you will get the answers very quickly. Okay, the sum of 5 consecutive integers can be 100. He is using the word can be. So if one is possible, then that is done for us. We will try to check here. See here, a minus 2 plus a minus 1 plus a plus 1 plus a plus 2. This should be equal to what? According to the question, 100. Or the given first statement, 100. So minus 2 plus 2 will get cancelled, plus 1 minus 1 will get cancelled. I will be left with only a's. So 5a is equal to 100. A value will become what for me here? 20. A value is 20. So now what happens to my numbers? 20, 21, 19, 22 and 18. Yes, the sum of 5 consecutive integers can be equal to 100. Yes, the first statement is correct. First statement is correct. Next one, the product of 3 consecutive natural numbers. Please observe here, students, natural numbers can be equal to their sum. Product of 3 consecutive natural numbers, what I can take now? Just now I told you how you will take. One is a minus 1, a plus 1. Now these 3 are 3 consecutive integers, natural numbers, right? 3 consecutive natural numbers. Yes, they are 3 consecutive natural numbers. Now what they are telling is product of 3 natural numbers can be equal to their sum. That means what? A minus 1 into a plus 1 should be equal to a minus 1 plus a plus 1. We will check whether it is possible or not now. Minus 1 plus 1 will get cancelled. What I will have here? A plus b into a minus b. A plus b into a minus b, what it becomes? A square minus b square into a. This a is equal to 3a. A square minus 1 into a into is equal to 3a. So a will get cancelled for me here. So now what happens for me here? A square minus 1 is equal to 3. A square value will become 4. So that a value becomes what? 2. If a is 2, what about the 3 natural numbers? 1, 2 and 3. Product of these 3 numbers is 1 into 2 into 3, 6, and sum of these 3 numbers is also 6. So that means the product of 3 consecutive natural numbers can be, not always, can be, yes, can be equal to their sum. Yes, this one is also correct. So the question is, which of the above statements is or are correct? Here both the statements are correct. Here both the statements are correct. See here, students, that while the taking of values in this manner, this is the advantage. We will get the answers very quickly without any, what we can say, discrepancy. So try to take the values consecutive, not only in this problem, you may come across in some other case also to take some consecutive integers or consecutive natural numbers. Please try to take in this manner. Some plus values and some negative values, then easily you will get the answer. Next, the number 21a35b4, see here, 21a35b4 is divisible by 3. So that means 2 plus 1 plus a plus 3 plus 5 plus b plus 4 is divisible by what? 3. Okay, is divisible by 3, where a and b are non-zero digits. A and b are non-zero digits. Then what is the maximum possible value for a plus b? They are asking us maximum possible value for a plus b. Now please try to add it. 3 plus 2 plus 1, it is 3. 3 plus 3, 6. 6 plus 5, it becomes what? 11. 11 plus 4, 15. So 15 plus a plus b by 3. 15 plus a plus b by 3. Now please see here, students, what they are using? Non-zero digits. Non-zero digits. If they use a word distinct, then I cannot take both values as same. But here he is not using the word distinct. Here he is not using the word distinct. So I can take a and b values as equal values also. Okay. Here the word distinct is not used. So I can take a value and b value as a equal digit. There is no wrong in that. Now please see here, 15 is divisible by 3. Yes. 15 is divisible by 3. Now tell me, what is the maximum value of a plus b? Two single digits whose sum should be divisible by 3. 9 plus 9, right? 9 plus 9 is 18. 18 is divisible by 3. Yes, already 15 is divisible by 3. So no need to worry about this 15. Put that aside. Now a and b are there. I can take them as equal values. There is no wrong in that. Why? Because he didn't use the word distinct here. If he had used the word distinct means, I would have taken 9 and 6. Understood? but he didn't use the word distinct, so I can take them equal values. So 9 plus 9, what it is? 18. So the maximum value of a plus b I can take here is 18. 18. Okay. If they use the word distinct means, then our answer will be changed to 15. Understood, students? So with one word, our answer may vary. Please try to observe the things carefully. Next one. The number 2, 4, A, 5B is divisible by 6. Okay, good. A and B are distinct non-zero digits. If A is an odd digit, then how many possible values are there for A plus B? That is the question for us here, student. First of all, is divisible by 6 means what? Any number which is divisible by both 2 and 3, then it is divisible by 6, right? Then it is divisible by 6. That means it should be divisible by both 2 and 3. It should be divisible by both 2 and 3. See here, which numbers will be divisible by 2? Which numbers will be divisible by 2? Only even numbers are divisible. All the even numbers are divisible by 2. That means, what should be my B here? B should be even. What should be my B here? B should be even. Definitely B should be even, then only this number will become even. Even or 0. Even or 0. It can be 0 also, there is no wrong in that. But B should be an even number. Okay, why I am not taking 0? Non-zero digits, sorry. I cannot take B as 0 also. The reason is, they are non-zero zeros and distinct non-zero digits. That means A and B values cannot be equal. And next thing in the question, very clearly they said that A is an odd digit. A is an odd digit and B is an even digit. A is an odd digit and B is an even digit. Okay, good, superb. Okay, now it should be divisible by both 2 and 3. From this, I can tell that B is even number and A is an odd number. Now we will check with the divisibility rule of 3. What divisibility rule of 3 says us? 2 plus 4 plus A plus 5 plus B should be divisible by what? 3. Should be divisible by what? 3. That means what happens to this? 2 plus 4, what it becomes? 6. 6 plus 5, 11. 11 plus A plus B should be divisible by 3. 11 plus A plus B should be divisible by 3. Now tell me, what are the, first of all, in general, tell me what are the possible values for A plus B I can take? A plus B I can take 4. The reason is 11 plus 4, 15. 15 is divisible by 3. There is chance. Next, A plus B value I can take 7. What is the reason? 11 plus 7, it becomes 18. 18 is divisible. Yes, there is a chance. Next, A plus B can be 10. If A plus B is 10, 11 plus 10, it becomes 21. There is chance. Next, A plus B can be 13. A plus, add simply 3, 3, 3. That's it. 13 plus 11, it becomes 24. Next, A plus B can be 16. Why? Because 11 plus 16, it becomes 27. Next, can A plus B become 19? Is there chance of A plus B becoming 19? No, no chance. The reason is, if I take the highest values, I cannot take them even 9 and 9 also. Why? Because they clearly mention that those two are distinct. And we also know that A is odd and B is even. How they both can be equal? It is not possible. Right? Next observation, what we need to make is, odd plus even. What should be our output? In our previous classes we have seen. When we add an odd number with even number, what is the result we will get? When we add odd number with even number, take a simple example, 1 plus 2. What it is? 3. 3 should be what? An odd number. So that means we already know that A is odd and B is even. That means sum of these two should become what? An odd number. That because of that reason, A plus B 4 is gone, A plus B 10 is gone, A plus B 16 is also gone. The reason is, this is the reason. When we add an odd number with even number, the output should be an odd number. Okay, in our previous classes we discussed this one, students. Please go through those videos so that you will get a clear idea. And if not also no problem, a general case only. Odd plus even, what I should be my output? Odd. Because of that reason, 4, 10 and 16 chances are gone. We cannot take their sum as 4, 10 and 16. Now we have only two chances. I should take A plus B as 7 or A plus B as 13. Okay, now we will be A plus B as 7. Next, A plus B as 13. And one more thing we should keep in our mind, A should be odd, B should be even. So what I can take? 1 and 6. Yes, there is a chance. Next, 3 and 4. There is a chance. Next, what I can take here? 5 and 2. There is a chance. Am I correct? Is there any other possibility apart from this? They are distinct non-zero digits, so I cannot take 0 also here. So 1, 3, 5, 6, 4, 2. Chances are there, right? Yes. These are the only chances for 7. Next, when it comes to 13, what are the chances I can have? Can I take 1 and 12? No. Why? Because b should be a single digit. So the minimum value of b starts from what? 4. Then what will be a? It becomes 9. Next, if b is 6, what about a? It becomes 7. There is a possibility. If b is some 8, a will become what? 5. A becomes what? 5. Can I take b as 10 here? No, I cannot take. Can I take any other values here? No. So total how many chances I have here? 3. And how many chances I have here? 3. So 3 plus 3, 6 chances. So 6 chances for a plus b we have here, which satisfies the given condition that a should be an odd integer and indirectly b should be an even digit. Understood, students? See, it requires a lot of conceptual knowledge to solve this question. Anyway, we should identify the first and foremost thing is b should be an even digit from the divisibility rule of 2. Okay, after identifying it, one more thing which we need to identify is odd plus even should be what? Always an odd number. Odd plus even should be always an odd integer. Because of that reason, we are eliminating this 4, 10 and 16. Okay, if you get this idea, and the remaining things are very, very simple. Very, very simple. So, please concentrate on this type of things a lot, students. Why? Because in UPSC CSAT, I am not speaking about the other examinations. When it comes to UPSC CSAT especially, they are going to concentrate on this type of minute or small things and frame a question. So, you should have complete conceptual knowledge, then only you can answer them, else it is not at all possible. Okay, next one. What is the value of x? So that 7-digit number 565652. Okay, 5656 x 52 is divisible by 72. Is divisible by 72. Now, sir, we don't know the divisibility rule of 72. How we need to write? See here, students, any divisibility rule, how you will write the divisibility rule is, for example, if I want to write the divisibility rule for 30. What is the divisibility rule of 6? Just now we have seen 2 and 3, right? Any number which is divisible by both 2 and 3, then that number is divisible by 6. Now, when it comes to 30, how we need to write, sir? Actually, please see here, 30 I can write 1 into 30. 30 I can write it as 2 into 15. Okay, what I can write once again? 30 I can write as 3 into 10. Okay, next at the same time, what I can write? 30 value I can write as 6 into 5. Okay, like this I can write 30 value. Okay. Now, see here, which pair I need to choose, sir? You need to choose a co-prime pair. Actually, for 30, all these are co-primes only. For 30, all these are co-primes only. You can take any two. That means any number which is divisible by both 6 and 5, that number is divisible by 30. Any number which is divisible by both 3 and 10, that number is divisible by 30. Any number which is divisible by both 2 and 15 is also divisible by 30. Like this you can take. Okay, similarly, if I want to write the divisibility rule for 18, what 18 I can write? 1 into 18, 2 into 9, 3 into 6. I cannot take 3 into 6 pair here. The reason is 3 and 6 are not co-primes. That means I can say that any number which is divisible by both 2 and 9 will be obviously divisible by 18. But I cannot say that any number which is divisible by both 3 and 2 is divisible by 18. I cannot use that word here. Why? Because 3 and 8 are not co-primes. 3 and 8 are not co-primes. Now, to avoid this situation, now similarly tell me what is the rule I can write for 72. Why? Because here our requirement is 72. What I will write is, see here 8 9s are 72, right? 8 and 9 are what? Co-primes. So that means what I can say? Any number which is divisible by both 8 and 9, that is divisible by 72. Any number which is divisible by both 8 and 9, that is divisible by 72. So, always you choose co-prime pairs. Then it becomes easy for you to write the divisibility rules of any huge number. Okay. So, the number which is divisible by 8 and 9, that will be divisible by what? 72. Any number which is divisible by 8 and 9 is divisible by 72. Now, see here, what is the divisibility rule of 9, students? Actually, sum of the digits should be divisible by 9. So, what is the sum? 5 plus 6, 11. 11 plus 5, it is 16. 16 plus 6, 22. 22 plus 5, it becomes 27. 27 plus 2, it becomes 29. So, 29 plus x should be divisible by what? 9. So, what is the value of x here becomes? X value should be what? 7. X value should be 7. Is there any other possibility apart from 7? No. We don't have any other choice. Sometimes we may also have multiple choice, but here in this case only one choice, that is what? 7. So that means x value should become what? 7. Now we will put 1 7 and we will try to check whether it is divisible by 8 or not. What is the divisibility rule of 8? Last 3 digits should be divisible by 8 or 3 digits should be 0. So my number will become what? X52 will become 752. 8 ones, 8 nines, 72. I will be left with 3. 3 2 means 8 fours are 32. So that is divisible by 8, right? So my last digit should, my x value is here how much? 7. X value is 7. Okay, you need to do in this manner. Next one. In how many ways 378 mobile phones be shared equally among the students present in the classroom? This case is nothing but indirectly to find the factors. In how many ways we can divide this 378 chocolates? We don't know the strength in the class. Students present in a classroom. Okay, we don't know the exact strength in that class. There can be only one student. If there is only one student, what you will do? You will give entire 378 chocolates to him. Okay, when we can distribute equally, tell me first of all. That means the number of students in the class should be definitely dividing this 378. Then only I can divide it equally, right? For example, see here students. There I have 378 mobiles. For example, assume that there are 5 students in the classroom. For example, assume that there are 5 students in the classroom. Then can I divide it equally among the students? Is it possible for me? Why? Because 378 by 5 I will get in decimal points. Is it possible to break a mobile phone and distribute among the students? It is not at all possible. That means the students in the classroom should be in what manner? Means that value should divide this 378. That is indirectly number of students in class should be factor of 378. Should be factor of 378. Then only we can divide equally, right? Then only we can divide equally. Else we cannot divide equally. See, just now I have told you 378. If there are 5 students in the class, I cannot divide that equally. Why? Because 5 is not a factor of 378. But for example, if I have 2 students in the classroom, I can divide it equally, right? Why? Because 2 is a factor for 378. So what I will do? 378 by 2. 378 by 2 and each student will get how much? 189 mobiles. Each student will get 189 mobiles. So that means the number of students should be a factor of the 378. Then only they can divide equally. Now this question is nothing but we need to find the number of factors for 378. Then we can divide in that many different ways. Okay, this question is indirectly to find the number of factors for 378. So how you will find the number of factors for 378 students? Please see here. 378, 2, 1, 8, 9. Next in 3 table, what I will get here? 63. Am I correct? Yes. 2, 3 and 63. That is fine. Next, what I will get here? 3 21s. Next 3 7s. 3 7s. Okay. So the number of students or the values what we will get here? 2, 3, 3, 3, 7. So 2 into 3 to the power of 3 into 7 to the power of 1. 2 into 3 to the power of 3 into 7 to the power of 1. So the number of factors here will become what? Add 1 to the powers and multiply them. How we will find the number of factors? We have seen in our previous session. Okay, so what I will get here? 1 plus 1 into 3 plus 1 into 1 plus 1. 1 plus 1. Add 1 to the powers and multiply them. Okay, so to find the number of factors. So what it becomes? 2 into 4 into 2. 2 4s are 8, 8 2s are 16. So total how many, in how many different ways we can divide 378 into equal mobile, distribute equally means in 16 different ways. If there is only one student, we can give all the mobiles to him. If there are 2 students, we can give him. If there are 3 students, like this, we can distribute them in 16 different ways. 16 different ways. Then only it is possible to divide equally. That means this question is indirectly to find the number of factors for 378 students. So the first and foremost thing which you need to understand is this is the concept. Definitely the number of students in the class should be factor of 378. Then only we can distribute them equally. Else we cannot distribute them equally. Okay, right. Next one. See the next question. Consider the following statements and question given below. Okay, what is x? The question is we need to tell what is the value of x. Now first statement, x is an integer between 25 and 30. Between 25 and 30, what are the integers do we have actually? We have 26, 27, 28 and 29. Between 25 and 30. So with this statement, first statement, can I tell my answer? Why? Because I have 4 choices. It can be any value from these 4 values. Okay, so with the help of only first statement, I cannot tell what is the exact value of x. Now I will see my second statement. What is the second statement? Second statement is x is a prime number. See, there are infinite prime numbers, right? So 2, 3, 5, 7, 11, 13, like this we have infinite prime numbers. So by seeing the second statement, can I tell my answer what is the value of x? No, I cannot tell exactly. Now I will combine these 2 statements, first statement and second statement. When I combine this first statement and second statement, what is the prime number in this one? 29, right? Only one number. Now when I combine these 2 things, when I combine this first statement and second statement, I can say that x's value is 29. I can tell the value of x value is 29, right? Yes, I can tell. So what will be our answer? First option is statement 1 alone is sufficient to, no, with statement 1 we have 4 choices, we cannot tell. Statement 2 alone, no, we have infinite choices. Both statement 1 and statement 2 are required to answer the question, yes. We require both statements, then only we can say a single value for x, that is 29. Okay, we will see the next one. Next question. Integers are listed from 400 to 700. Okay. How many integers have 2 at units place and 3 at tens place? Okay. They listed some 400 to 700 numbers, and that means all the numbers will be of 3-digit numbers. Yes, definitely they will be of 3-digit numbers. What they are telling? Units place, 2 at units place, that means 2 will occupy the units place, fixed place, and 3 at tens place. 3 will be occupying the tens place. So these 2 places are filled. Now tell me, what are the chances for this place? My range is from 400 to 700, right? 400 to 700. So what are the values I can take in place of my hundreds place? Either I can take 4, or I can take 5, or I can take 6. Am I correct? If I take a value less than 4, what it becomes? It will fall under 400. If I take a value equal to 7 or greater than 7, it will fall beyond 700. So what are the possibilities I can take is, it can be either 432, 532 or 632. So how many values are there? How many integers are there? Only 3 integers are there for us. What are those integers? 432, 532 and 632. So whenever you see this type of question, please try to think in this manner. Next one. How many zeros are there at the end of the product of all prime numbers between 100 and 1000? Between 100 and 1000. See here students, when we will get a 0, we discussed already number of zeros concept. When we get a 0, when we have a pair of 5 and 2, we will get a 0. A pair of 5 and 2 will give us a 0. Now see here what they are telling, how many number of zeros we will get at the end of all the prime numbers from 100 to 1000. See students, except 2, all the remaining prime numbers are what? Except 2, all the remaining prime numbers are odd numbers. All the remaining prime numbers are odd numbers, right? We know it very clearly. Now from 100 to 1000, what we can say, all the numbers will be of odd numbers, and we don't even have 5s in them also. We will not have 1 5 and we will not have any 2s. So that means, will we have a pair of 5 and 2? We will not have a pair of 5 and 2. Because of that reason, we will have 0 zeros. We will not have a 0 at the end of the product of all the prime numbers between 100 and 1000. For example, if our question is, how many number of zeros will be there at the end of product of all the prime numbers? If they use the word all the prime numbers, then we will have 1 0. Why? Because see here, 2 and 5 we will have one pair. Why? Because 2 is a prime number and 5 is a. We will have one pair and we will have 1 0 if we consider all the prime numbers. But here our range is from 100 to 1000, we will not have zeros at all. Okay. Next. Gopika started typing from 1. Okay. She typed till 25. Okay, good. And then gave balance work to Bhavana. If Bhavana typed a total of 208 digits, right? Gopika typed till what? 25 number, right? Till the number 25. Now tell me, after 25, more how many 2-digit numbers will be there for me? After 25, more how many 2-digit numbers will be there for me? Students, if you observe carefully, how many 2-digit numbers will be there after 25? After 25, we will have 74 2-digit numbers. We will have 74 2-digit numbers. After 25, we will have 74 2-digit numbers. So, for these 74 2-digit numbers, how many digits will be used? 2 into 74. 148 digits will be used. 148 digits will be used to write all the 2-digit numbers by whom? By Bhavana. By Bhavana. Now, but actually Bhavana used a total of how many digits? 208 digits. Bhavana used a total of 208 digits. In the 208, already 148 will be used to write the 2-digit numbers, right? So, 208 minus 148, that means more 60 digits. These 60 digits are used to write what type of digit numbers? 3-digit numbers, right? These 60 digits are used to write what type of numbers? 3-digit numbers. So, total how many 3-digit numbers she might have written? 60 by 3. That means she will write 23-digit numbers. She will write 23-digit numbers. Now tell me, what is the 20th 3-digit number? What is the 20th 3-digit number? That is 119. Please be careful, students. Why? Because the first 3-digit number is 100. So from 0 it will start. So our 20th 3-digit number will become 119. 119. Don't mark your answer as 120. There is a chance of writing your answer as 120. Please be careful. The first 3-digit number is 100. From there we need to write the 20th, right? So 20th 3-digit number will become 119. 119. That means Bhavana is going to write up to 119 numbers. Okay. Right. Next. See here. X is a prime number greater than 3. Okay. X is a prime number greater than 3. When x is divided by 6, the remainder obtained is r. Okay, good. Then which of the following is true? See here, students, while discussing about prime numbers in our first session, very clearly I told you all the prime numbers above 3 or greater than 3 can be written as what? 6k plus or minus 1. Did you remember this one? We can write all the prime numbers above 3 as 6k plus or minus 1. So that means I can take them as either 6k plus 1 or 6k minus 1. 6k plus 1 or 6k minus 1. Now, these numbers are divided with what? 6. These numbers are divided with 6. So, please try to observe the remainder. 6k by 6. What will be the remainder? 0. Why? Because 6 will be cancelled and it is a multiple. And 1 by 6, what is the remainder I will get here? 1. Okay. Next 6k by 6, what is the remainder? 0. So that means 0 plus 1, actually here it will become 1. This is 0 and 1 by 6, what you will get? 1. So 0 minus 1. Why? Because here it is minus, right? Minus 1. Will we write our answer in minus? No. So for that what I will do? 6 minus 1 and I will write my remainder as 5. I will write my remainder as 5. So that means what are the values of, what are the remainders I will get here? I may get 1 or 5. I will get remainder as 1 or else 5. So please observe the remainders. R can only be 1 or 5. Actually this is the correct answer, but we will see the remaining options. R can be 1, 3 or 5 but not 2. Is R is becoming 3 here? No. R can be either 1 or 5. Next, R cannot be 1. R can be 1, right? That is also wrong. Next, R can be 1, 2 or 5 but not 3. Are we getting R value as a 2 here? No. So this one is also wrong. So R can be only 1 or 5. 1 or 5. See here, students, this is purely conceptual question. If you don't know that, we can write all the prime numbers greater than 3 as 6k plus or minus 1. You will not get the answer at all. If you have the knowledge of writing the prime number as 6k plus or minus 1, then only you can answer this question, else it is not possible to answer. Next one. Consider the following statements in respect to the sum s is equal to x plus y plus z, where x, y, z are distinct prime numbers each less than 10. Okay. So what they are telling here, s is equal to x plus y plus z. S is equal to x plus y plus z, Now they are distinct prime numbers less than 10. So tell me what are the prime numbers which are less than 10? We have 2, 3, 5 and 7. 2, 3, 5 and 7. Now they are telling us, they have given us three statements. The unit digit of S can be 0. Can be means try to get a value as something which ends with 0. 2 plus 3 plus 5. What it is? 10. It is ending with 0, right? So yes, this can be possible. So can be means if one value is satisfied, that is enough. That one is true. Next, the unit digit of S can be 9. Please add any 3 so that the unit digit is 9. 2 plus 3 is okay. This 3 we have already added, that is 10. So 2, 3 and 7. What you will get? 5 plus 7, it becomes 12. That is not possible. Next, 3, 5, 7. If I add 3, 5, 7, what it becomes? 8 plus 7, it becomes 15. That is not possible. Next, 3, 7 and 2. That is not possible. Or else 5, 7 and 2. 14. That is also not possible. So, whatever the values if you add also, you will not get the unit digit as 9. So, we are not at all getting the unit digit as 9 here. That one is also gone. Next, the unit digit of S can be 5. Yes, just now we were calculating somewhere we got 5. What? Okay. 3 plus 5 plus 7. What it is? 3 plus 5 is 8. 8 plus 7 it is 15. Okay. So, that means the unit digit of S can be what? 5. The unit digit of S can be 5. If one value is satisfied, that is enough. Whenever the case is can be. Which of the following statement is given above are correct? So, here 1 and 3 are correct. 1 and 3 are correct for us here. Okay. The next one. Okay. 222 power 333 plus 333 power 222. Okay. The question is actually 222 power 333 plus 333 power 322. Is divisible by which of the following numbers? Is divisible by which of the following numbers? Now see here, in options I have 2, 3, 37, 2, 3, 37. Always I have 2, 3 and 37. Always I have 2, 3 and 37. Now we will check randomly what will happen for us. See here students, first of all I will check 2. When I check with 2, what happens is whether it is going to divide, this value is divisible by 2 or not. 322 is divisible by 2? Yes. When it comes to 333, is 333 divisible by 2? No. Why? Because 333 is an odd number. 333 is an odd number. Irrespective of its power, it is not at all divisible. If we use the divisibility rule concept also, 322 by 2, what is the remainder? 0. 0 power 333 plus 333 by 2. What is the remainder? I will have 1. So 1 to the power of 322. So what is the remainder we will get here? 1. That means this number is not at all divisible by 3. Now please try to take the help of this 2 concept. Actually with that you will get the answer students. 2 and 3 but not 37. Actually it is not divisible by 2. So this is not my correct answer. Next 2 and 37 but not 3. This one is also gone. Why? Because it is not divisible by 2. Next 2, 3 and 37. This one is also gone. So we are left with only one option, that is B. We are left with only one option, that is B. Now we will verify, just for your knowledge sake, we will try to verify it. What you will get? 222 power 333 plus 333 power 322. First with 3 I will check. What is the divisibility rule of 3? Sum of the digits should be divisible by 3. So 2 plus 2 plus 2 it becomes 6. As 6 is divisible by 3. So you will get remainder 0 here. Next here 333 9. 9 by 3 it is divisible by 3, 9 is divisible by 3, so here also you will get 0. So that means this value is divisible by 3, gone. Next 322 power 333 plus 333 power 322. It should be divisible by 37. Now if you observe carefully, 37 6 are 322. 37 6 are 322. So that means here you will get remainder as 0. So 0 power 333 0. Next 37 with what we can multiply? 9s. 37 9s is 333. 37 9s is 333. Here also you will get 0. So 0 plus 0 what it is? 0. So that means the given number is divisible by both 3 and 37. The given number is divisible by both 3 and 37, and so that we can write our answer as option B. Without doing this 2 also we can tell with only 2. See in options try to eliminate. Whenever you see these type of questions, first of all check with everything. Wherever 2 is not present, try to delete them. For example, if in case the 2 is dividing, then eliminate the options in which 2 is not there. in which 2 is not there. But here we are eliminating the options in which 2 is present. Okay, right. Next one. Let P and B be positive integers satisfying P less than Q and P plus Q is equal to K. What is the smallest? Okay. Does not determine P and Q uniquely. See students, while discussing our number system concept, we came across one thing, unique solution and multiple solutions. Unique solutions and multiple solution. What is unique solution means? If it satisfies only one pair, that means we should get x value as 1 and y value as something. X and y values we should get a fixed values, then we call it as unique pair. Multiple answer means where we can take multiple values for x and y. So that is called multiple cases. While discussing that number system, we came across this one students, concepts of number system. We solved this one. Now what they are telling here is cannot be, I cannot be determined as P plus Q. So what they are telling is P plus Q, okay, positive integers, P and Q be with the positive integers. Positive integers means from what we can take their values, from what values we can take P and Q as 1, 2, 3. 0 is not a positive integer. Remember this one carefully. Positive integers means you should take 1, 2, 3, 4, 5, 6. You should not take 0 at all in that cases. Remember this one. Okay. What is the smallest value of k? If we are adding two positive integers means my k value also will become what? An integer. A positive integer only, obviously. My k value also becomes a positive integer for me. So now what are the values of k I can take? Let us take from 1 for time being. Is it possible to take k value as 1? No, not at all. What is the reason? Two positive values means I can take a minimum of 1 here. So 1 plus 1 it can never be equal to 1. And one more thing, I cannot take them as 1 and 1 also. Why? If can I take k value as 2? No, I cannot take k value as 2. The reason is, if I take k value as 2, definitely p and q values I should take them as 1 and 1, which is not going to satisfy my condition p less than q. So I cannot take k value as 2. Next, I will take k value as 3. Yes, I can take k value as 3. So that what is the value of p I can take? I can take 1 and q value I can take it as 2, 3. Apart from this, can I take any other value? No. Are we getting the unique solution here? Yes, definitely p value should be 1 and q value should be 2. But our question is what? K does not determine P and Q uniquely. Does not determine. If they ask us determine uniquely means our answer will become 3. But here it should not determine uniquely. So I will go for next K value, that is K as 4. If I take K value as 4 students, now what happens? What are the values of P and Q I can take? I can take 1 and 3. Apart from 1 and 3, can I take any other value? No, I cannot take 2, 2. Why? Because if I take 2, 2, it will not satisfy this condition, P less than Q. So here also I have a unique solution. That means P value is 1 and Q value is 3. Here also I have unique solution, so I cannot consider these two as our answers. Why? Because here does not determine. If I take K value as 5, so what are the values I can take? I can take 1 plus 4 as 5, or I can take 2 plus 3 as 5. So here is the value of P and Q are unique here? No. P and Q have multiple chances here. P and Q can be 1 and 4 or 2 and 3. So multiple chances. So here it is not determining a unique solution for us. Here it is not determining a unique solution for us. So because of that reason, K value as 5 will be our answer. Why? Because our question is smallest value of K. That does not determine P and Q uniquely. So we can take K value as 5, which will not determine the values as uniquely. Which will not determine the values uniquely. Understood students? Very simple. Or else, sir, we don't understand all these things means very simple. Substitute anyway the values which given for us are K values only, right? So what they have given? P plus Q, the first option, smallest, right? So come from the smallest value. P plus Q is 3. Directly take K value as 3. P plus Q as 3. Now what are the values of P and Q? I can take 1 and 2. Don't say that, sir, I will take 0 and 3. You cannot take these values as 0 and 3. Why? Because P and Q are what? Positive integers. 0 is not a positive integer. Once again I am repeating. 0 is not a positive integer, so that you cannot take 0 and 3. So here you are getting a unique solution. Only one chance. Next, P plus Q. What is the next option for me? 4. So what are the values of P and Q I can take? I can take 1 and 3. Apart from 1 and 3, is there any other choice? Can I take them as 2 and 2? No, I cannot take. Why? Because P value should be less than Q. So this choice is also not satisfying the multiple answer case. Here does not determine uniquely. So next, P plus Q, what they given for you? 5. So what are the values of P and Q I can take? I can take 1, 4 or 2, 3. So here I have multiple answers, right? Multiple answers. So my answer will become 5. My answer becomes 5 here. Okay, in this manner you need to solve this type of question, students. Okay, right? With this we solved some of the practice questions from these number systems. In our next session we will see some of the previous year's questions from the same concept called number system, and then we will move to the other concepts, right? Thank you very much.